Hi, I'm Zhoming Wu, and I'm gonna record the homework solution video for question number 2 in homework 10 for the course probability and stochastic processes. So for this problem, we're asked to collect the definition and definition of probability of the following 8 stochastic processes. The first one is Y-sense stationary processes, and the second is independent increment process. And third is Markov process. Fourth is normal process, which is also known as Gaussian process. And fifth is strict sense stationary process, which is also called SSS. And sixth is white noise. And seventh is mean ergodic process. And eighth is called martingales. So for the first one, the Y-sense stationary process is defined as a process mean is constant, and its autocorrelation is a function of the time difference. So my understanding of this process is when input is WSS process, the output of this function will be a stable LTI system is also as a WSS. So for the second process is called independent increment process. It means the xt1 minus xt2 and xt3 minus xt4 on non-overlapping intervals are independent. So my understanding on this process is this process property is related to Markov process. So for the third process, Markov process, so it means the process part has no influence on the future when present is known. So my understanding of this process is the many processes I mentioned before, like Poisson process and Poisson impulse and semi-random telegraph and random telegraph and random work and Wiener's process are all belong to Markov process. So for the first normal process is defined as the following equation right here: fx of x1, x2 all the way to xn and t1, t2 all the way to tn is equals to the formula right here. So where x is equals to the matrix of from x1 to the all the way to xn, and the larger x is the matrix of xt1 all the way to xtn. And my understanding of this process is normal processes are larger class of stochastic processes. So for the fifth process is called strict sense stationary process. It means process statistics is not affected by shift on the time axis. So my understanding of this process is the SSS requires the equation right here, which is very hard to fulfill. So for only a few processes can be called SS process. So for the sixth one, it's called Y noise. It means process. Suppose we have a process Vt, and if the expectation of Vt is equals to 0 and the R way of T1 T2 is equals to Q T1 and times the theta T1 minus T2, it can be called Y noise. So my understanding of this process is its mean is 0 and its impulse autocorrelation function. So for the seventh one, it's mean ergodic process. So it means it's process xt, and it's defined as the equation right here. So the limitation of limitation when t tends to be infinity of 1 divided by 2t, and derivative of differentiation of xt dt from negative t to t is equal to the ext. So in mean square sense, so my understanding of mean square sense is this is one kind of consistency. And for the eighth process is called martingale. So it means process xt expectation of xt under the condition that xs is equal to x1 will be equal to x1, whereas less than or equal to t. So my understanding of this process is conditional, and its mean is equals to the condition stands for this process. And that's the solution for this question, and thanks for watching.